Hi guys, we're going to be looking at topic 3, and I'm so excited that I get to do this one with you guys. I often call topic 3 the donut area because what you're looking at is area of a shaded region, which sounds much more complicated than it is. I actually think about it like a donut, and I don't want a green donut here, so let me get an orange. So if I were to look at a donut and it wasn't jelly filled, because if it were jelly filled or cream filled, it would just look like this, right? And then you bite into it and you get all that yummy jelly. But let's pretend like it's a normal one where there's a hole poked out of it, right? And so you'd have this donut and you'd have this donut hole in the middle of it. So what you want to think about is like, how would I find the area of only the donut, right? And this is why I call it donut area, because I want to know what's the area of just the donut. And maybe I could shade it like this. Oh, that's prettier. Y'all like this chalkboard that actually exists in my bedroom? So what happens here is I might want to know what's the area of the donut. And so in order to do that, what I would do is, just like when I make a donut, I make the whole donut and then I poke the hole out of the middle and I remove it. So the same thing is going to happen here, where we're looking at what's the area of the whole figure and then removing the parts that I don't want, right? The parts that aren't shaded. So donut area, here we go. I might pop up again later, but let's see. So when we look at this, and I'm going to go in presentation mode, so I'll see you later. Here we go. Here's what a general shaded region problem will look like, where you are looking for the area of like this gray part, and it's usually, you know, something like this, where it looks like maybe it's like 4 triangle-ish type things, and it's like, I don't know how to find the area of the triangle-ish type things. But what I could do is I could take this whole square and remove the hole from the middle of it, right? So if I were doing that, then my donut would be the square, 20 times 20, or 400. And then I'd find the area of the circle, pi r squared, where the radius would be just 10, right? Half that length. So pi times 10 squared. And I would do 400 minus pi times 10 squared. It really is that easy when you're doing this, okay? It's not, try not to make this something that's super duper complicated, because it's really not. Oh, I'm back. I didn't mean to be. I was trying to get myself in a mode where I could actually write on my screen. Well, you're going to see me the whole time then. Cool. So I don't want you to see my closet, though. It is not clean. All right. So let's just look at this problem here. So we're going to do 3 steps. First, we're going to find the area of the square, which is the area of the outer region. Okay. And so I always want to ask myself, which figure is the outer figure? I got to figure that out first. Does outer have 2 T's in it? I actually don't know now that I wrote that. Anyway, we're going to pretend like it does. Okay, so once I find the area of the outside figure, which is the square in this case, then I'm going to find the area of the circle, which is the inside figure. So then I find the area of the inside figure. Ooh. And you can't see that. There we go. And then once I have the area of the outside and the area of the inside, then I'm just going to subtract them from each other, right? So then once I have this, then I just want a minus sign between them. So I'm going to do outside minus inside every time. So if I want the area of this square, let me make myself smaller here. Smaller. The area of this square, then I'm going to use side times side, right? Length times width. And that's going to end up being 20 times 20, which is 400. And then I'm going to find the area of the circle, which is pi r squared. And so that means I need to find the radius. And if I look at this picture here, if this whole length is 20, the radius is just going to be from the center to the edge, right? So there's my radius, which is going to be half of 20 or just 10. Okay? There we go. So pi, because maybe you're using your phone, you can do 3.14. And then the radius is 10 centimeters, and then we squared. And so the area of the circle is 314 square centimeters. So now I'm going to take that whole square and I'm going to remove the circle from it. So I'm going to do square minus circle. Okay? So square minus circle would be 400 minus 314, which would leave me with 86 square centimeters. So now would be a great time to hit pause and make sure that you have this example written down beautifully, just like this. All right. Example problem number 2, where I remove that radius. Oh, that's better. Okay, so we have to decide what's the outside figure, what's the inside figure, what's the outside figure, what's the inside figure. So in this case, we've got this rectangle. Look, I could use a piece of paper like a rectangle, right? But I really only want that L shape, right? So I don't have a normal thing to write on, but let me use chalk. Can you see it? Can you? Right, it's got writing on it. Just ignore the writing. So how would I find the area of just this part? Well, that's easy. I have a piece of paper. I don't have scissors, but I could just literally remove it, right? I would take this, I'm keep going the wrong way. I would take this, I want this, so I would take this whole rectangle and I'd remove the small part. And that would be it. All right, so let's do that. The large rectangle can be found with length times width, which in this case is 30 times 15. So when you're looking at this figure, make sure you don't pull this 4 like it's the whole side length. Notice how it's down here in a weird place. Go ahead and double check the other side to make sure it matches, right? Oh, okay, no. This is actually 15 by 30 for that outer rectangle. And so 30 times 15 is 450. So the area of the whole rectangle is 450. All right, so now let's look at a small rectangle, and because, why make things easy, I didn't tell you the measurements. So we know we're gonna need length times width. So now we have to find them. So we know this whole side is 15. And we know this little part right here is 4. So to find what you don't know, take the whole amount. That's not a subtraction sign, that's an arrow. How about that? Take the whole side, subtract what you know, and that will give you what you don't. So that's 11. So same thing, this whole side is 30, right? Opposite side. So to find this guy, I would do 30. That's a 1, and I want a 3. So let's erase that. There we go. So I'm going to do 30. That's the whole side minus the part that I know, which is 8. And that's going to give me the part that I don't know, and that is 22. Okay, we're about to find out if I did my math right, because now I think the length is, I didn't do my math right. Let me look, hang on. Okay, so I didn't make this lesson, but I will make a correction to it. Let's call this, let's see, what would it be? 2. And so that the lesson actually the problem actually makes sense. So let's say the whole side is 30 and this bit is 2. So 30 minus 2 is 28. Now it matches, right? So now I can find the area of this white rectangle right here. I'm an artist. By doing 11 times 28. And that will give you 308, right? Okay, then I can find the area of the shaded region by doing outer, which I think is spelled wrong, minus inner. And so that's going to be big rectangle minus small rectangle, big rectangle minus small rectangle. Another kind of like clue that you're probably subtracting the wrong way is if you're subtracting and you get a negative number, you probably subtracted the wrong direction, because the one that's inside should have a lot smaller of an area than the one that's on the outside. And you don't want a negative area. Okay, so large minus small will be 450 minus 308, which is 142 square centimeters. Okay, now would be a good time to hit pause and to write some notes. You know, I'm not going through each time the sentence, you know, that I like to see at the end. And I should be, the area of the shaded region is 142 square centimeters. You know, I like that sentence at the end. Okay. Now, in this problem, if I want to do outer minus inner, I have two inners. I have two holes they're cutting out of this donut. For those of you who like donut holes more than donuts, this is your kind of donut, because you got a donut and two holes. So that means my outer minus my inner minus a second inner. Okay? So let's look at this guy. He has 3 circles, so I went ahead and I've got circle radius 3, that's this guy. Circle radius 2, that's this guy. And then the largest outside circle, and when I subtract, that's going to give me this, excuse me, this gray region here. Okay, so circle radius 3 is super easy. Pi r squared, which is just 3.14 times 3 squared, which is 9 times 9. So if you're doing this in your phone, I recommend, or I will say the way that I would do it, right, is I would type 3.14 times 9, and then I would just hit times 9 again, and that would give me, whoa, what should be the answer to, you guys, I'm struggle busing. I think I had something in my calculator when I started. Let me try again. And I kind of knew that was too big, like 9 times 3 is 27, and 27 times 3 is not this. Hang on. Guys, I'm going to get it together. I promise I'm going to get it together. So this is fine. This makes sense, right? Because 3 times 9 is 27. So a little more than 3 times 9 is a little more than 27. Yeah, it's fine. Okay, I'm just, my phone. But trying to make logical sense out of it. If you get a crazy answer from your phone, make sure you double check that. Okay? All right, so circle radius 2. I said that was super easy last time. Really, it is easy. So let's try again. Pi r squared. R is 2. So 3.14. And this time I think I'll make sure I start with 0. 3.14 times 2 times 2 is 12.56. Please, for the love of all that is holy. Okay, so now I need the largest circle. And this one is actually admittedly a little more complicated. Okay, so we've got to figure out what in the world is the radius of this circle. And so let's assume, because we couldn't figure it out otherwise, that this is going to go through the center of the circle, okay? Well, I know this radius is also 2, and I know this radius is also 3. So the diameter of the entire circle would be 3 plus 3 plus 2 plus 2. 3 plus 3 is 6, 7, 8, 9, 10. That makes the diameter of the circle 10. And if I take half of 10, that means my radius is going to be 5, right? Okay, so pi r squared, pi times 5 squared, not getting my phone this time for you guys, is 78.5. I'm just going to check it in my head. 25 times 3 is 75. 78 makes sense to me, okay? Because it's a little more than 3, so it'd be a little more than 75. All right, so now what do? I take the big circle, and I subtract a little circle, and the other little circle, and that's going to give me that shaded region area. So, big circle minus small circle equals 37.68 square units. And if you had done the circle radius 2 first, like if not first, but if you had done large circle minus radius 2 minus radius 3, you would get the exact same answer, okay? Just that's the way subtraction works, as long as you take the subtraction sign with it. Okay, so the area of the shaded region is 37.68 square units. Now's a great time to hit pause. All right, example problem number O. What do we have here? We've got the whole shaded region is 32. And we want to know the length of the missing side of the square that's inside of it. Okay, this one's actually kind of tough. So we have to figure out the area of this whole composite figure, or we have it. No, we don't. We have the area of the shaded region. We do need the area of the whole composite figure. Then we're going to subtract away this unknown area and set it equal to what we know to be the shaded area, okay? So rectangle 1, length times width. We're doing 5 times 3. 5 times 3, okay? So what we're doing here is we're splitting this up right here. And we're saying, okay, if this part's 7, then this part has to be 3, because 3 plus 7 is 10, right? Making the area of this first rectangle, let's call it rectangle 1, because I did in the notes, or I didn't, but these notes are. Okay, and that means it's 15 centimeters squared in here. Then we're going to find the area of this second rectangle, length times width again. Make sure you don't use that 10, because that's this whole piece right here. And so what we're going to do is we're going to do 7 times 3. That's this rectangle right here. And that's going to give us an area of 21. Okay? Then we're going to look for the area of the composite shape, meaning I want to combine area 1 and area 2 together. So all I need to do is add them. 15 and 21 make 36. So together, assuming the white square is not removed from the picture, this whole figure, this rectangle plus this rectangle, would be 36 square centimeters, okay? But I don't want this part. I want this part removed from my L-shaped donut, okay? So when I'm looking for this, I wonder if I can't just say, okay, well, I know what the area of a square is, right? The area of a square is side times side, or x times x. So when I go to find this, right, then I'm going to say, okay, well, let's do my area of my composite shape minus the area that I know, and that's going to leave me with this side times side situation. And let me back up just a second, and it can explain what just happened. We said, let's take the composite figure. Let's say, because we're doing this a little backwards, okay? because we're looking for side. So we're saying, let's take the whole figure. Let's subtract the shaded region this time. What that's going to leave me with is just a little white square, right? If I take this rectangle plus this rectangle, and then I take away all the gray stuff, which is what's given to me right here. This is the gray stuff, okay? This is the whole thing. So I'm going to take whole thing minus gray stuff, and it's going to leave me with white square. And I want to know what's the side length for that square, right? So I know the area of that square is 4. All right, so if the area of that square is 4, and I know that area is equal to side squared, then I know that side squared has to be equal to 4, and I can just take the square root of both sides, and that would give me that side is equal to 2, right? So right here, I would take the square root of both sides, and that would give me that the side of my unknown square, the side of this white square right here, is actually 2. Now that's kind of a complicated problem, right? There's another way we could have worked it out. Give me just a second. Okay, so what I could have done is I could have said, here's my outside, which is 36. That's the two rectangles combined. And then subtract the inside, which is the white square, just like we've been doing. Outside minus inside equals shaded region, which is 32. And set the equation up like this, okay? But remember, I told you, if you accidentally subtract your small minus your big, you're going to end up with a negative number, okay? And let me make myself a little bigger for just a second so you can see this a little better. There we go. Oh, yeah. So in this case, when I do this, when I solve this outer minus inner equals shaded region, I subtract 36 from each side. I get negative side squared is equal to negative 4. Well, I'm going to have to divide by negative 1 at this point and say, okay, I know side squared is going to be 4. And so if I take the square root of both sides, then I'm going to get that the side has to be 2 in this way. Okay? So what I just did is I said, I need an eraser. I said, let's call, and I used an S. Maybe it would make more sense for you guys if you use an X, right? X times X. And I just did outer minus inner equals shaded region and solve the equation this way. So this would be the other way, okay? Now it's a good time to pause and either write down what you see on the screen or what you see on the board, okay? Okay, next shaded region problem, we're looking at a triangle where you're basically like cutting off the tip of the triangle, right? But what we're looking for is, what's this side length? So you're literally, the shaded region here is this actually, it's a trapezoid is what it is. And so, but to me, it looks like you took this whole triangle and then you just cut off this part, right? So if I were to take a piece of paper and make a triangle out of it, hold on, I'll pause so this doesn't take forever. Got it. Okay, so if I take a triangle, and I know this is a little taller than the one you see, the area of the shaded region in this case is me just removing the tip of the triangle and ending up with this, okay? And wanting to know, given all that information, what's this length right here, okay? So in order to get this length, we've got to find some stuff. So the first thing we're going to do is we're going to look at that small triangle. And what we're told here is that the shaded region is 12 square centimeters. Okay, so this right here is 12 square centimeters, but not this part. But what we do know here about this small triangle, or the base of the big triangle, I should say, is that this is going to be equal to this. Okay? And if the whole thing is 8, and these two are equal to each other, then that means this guy right here has to be 4, and this guy right here has to be 4. They have to be the same, and together they have to equal 8. So we know that the area of the small triangle is 1/2 base times height. And so I'm going to fix this as I go through it, because obviously it's not going to be 8, it's going to be 4. So let's see here what we got. This is going to be 3 times 4, and that gives us 12. So actually the answer is right on here. This is what I get for stealing somebody else's work. Oh no, you can see my closet. I'm going to leave it. Okay, so then we're going to look at the large triangle. And so this large triangle is actually, thinking about it a little different, is actually the shaded region plus the little white triangle. It's a weird way to think about it, right? Because we've done this whole thing with subtraction, but this one can actually be done with addition. So we know this shaded region is 12. And we just determined that the little white triangle's area is also 12. So if we want to find the area of the large triangle, and why do we want the area of the large triangle? Oh, because we need to know what that is. That's why. And so that's part of that large triangle. So the area of that large triangle would be 12 plus 12, which is 24. Okay, so now I'm looking at this triangle, and I'm going to draw him. He looks like this. Ooh, I am an artiste. And its area is 24. And its base is 8. And its height is, I don't know, let's call it x, right? Because it's actually what we want out of this problem. Well, now I can set up an equation. I can say, okay, the area of a triangle is 1/2 base times height. And the area is 24. And the base is 8. And I think you saw this in a previous video, but remember that we've got commutative property working to our advantage here. You know, we're looking at 0.5 times b times 8. And we really want to be able to multiply these two, and we can because of the way commutative property works. We could rewrite this as 0.5 times 8 times b, and I know I didn't write 1/2, I wrote 0.5, it's because I'm lazy. And then half of 8, or 0.5 times 8, that's just 4. That's where that 4b is coming from, okay? So you got 24 equals 4b, and you divide by 4, and you end up with b is 12. And I'm not, 100% certain why the author of this slide decided not to call the base 8 and the height. Like, I don't really understand why the height wouldn't be what's being solved for here. But basically, if this is confusing about why it's called b, why they use that variable, I'm also confused. So let's just call it x, okay? And let's call this x. And let's call this x. And that solves for that height of that triangle. Really, it doesn't matter because we could take that triangle and we could tilt it, and all of a sudden that does become the base. But I just don't want you to get hung up on that, okay? So in this problem, that unknown side is 12. And again, pause and write notes. Pause and write notes. Okay, so for the assignment on this one, you are going to go to your assignment 3, and you can either get there from this document, which is linked in like 17 places now, or to It's Learning and go to plans. This is topic 3. I'm currently making the video, that's why it's not linked. When you go to the quizzes assignment, you are going to have to create a quizzes account. And I want you to click the class period that you're in, make an account using your LR STEM Google account. Scroll to the bottom after you've done all that. All these directions are in there. And you're going to find topic 3 assignment. Your score will be based on your accuracy. So you can keep working it until you can make 100. Or you can only do it once and take the score that you get, whatever makes you happy. I wouldn't recommend that, but that's just me. Okay, guys, thanks for joining me for topic 3. There will be an assessment after this one. Bye, guys.